So hello everyone, today I'm going to talk about the Valide Sudoku problem. So given a 9 by 9 board, and we're going to check whether it is valid or not. So there are three rules. You need to check each row, each column, and each subgrid to find out whether there's some repetition in the digit from 1 to 9. And you only need to check the partial field board. We don't need to check whether it is solvable or not. And the empty space is filled with dot. So let me try to understand this problem. So given an input would be a board, 9 by 9 list. So you can see here is a string list. And then the output would be a simple Boolean number, true or false. So this problem is pretty straightforward for me because you just need to follow the rules. There are three rules, each column, each row, each subgrid. So we're going to have 3 for loops to check, to validate the board. The other thing is how to check repeated numbers. So there are several ways to do it. One of it is like you can create a flag list. So create a flag list to check how many times the number occurs. Or I can also create a dictionary to check if the key is in the dictionary, which means the number has occurred before. So I'm going to use the flag list to demo this. And then I'm going to plan stage. So first of all is I'm going to follow the rules. So I'm going to check row. I'm going to check each column. I'm going to check each subgrid. So for each row, I'm going to so for each row, so for I in range 9, maybe I should create a function to validate sudo just validate. Okay, validate for, and then I'm going to put this. So this is for each row. I'm going to create a flag list. So flag is equal to 0, times 9. And then for each item, so for j in range 9, for each item or for each column, I can check. So if this board ij, this position is not equal to dot, I'm going to mark flag board ij -1 equals to plus equal to 1. So what if it is already marked as 1? I mean, if the number has already occurred, so we need to check that. So we can do this if this guy is greater than 1, I'm going to return false. So we have already finished the row. So we can try to finish the column. It's pretty much the same. I just need to change a little bit. So this is for each column. And for each row, column, row, column, row, column. So let's review this. So if each column create a flag, and then for each row, if that item is not dot, I'm going to mark it plus equals to 1. And if it's greater than 1, so return false. Okay, good. So let's go to the check subgrid. So when we look at this, we start with 0, 0, index 0, 0. And then we check this subgrid. So the column is from 0 to 2. The row is also from 0 to 2. So we have 9 subgrid to check. So again, a for loop. So for row in range 0, 9, 3, so which is 0, 3, and 6. So 0, 3, and 6. And then we need to start a column for C in range 0, 9, 3. I'm going to go over this subgrid. So this is for each subgrid. I'm going to again for loop for I in range 3, for j in range 3. I'm going to check I'm going to check if row plus I, C plus J, row plus I, C plus J, oh, C plus J, row plus I, C plus J. I'm also going to create a flag. Same thing, create a flag here, and then check each subgrid. It looks fine after all of this. Return true. So I'm going to copy this and then run it. Odd equals to string not int. Oh, it's a string. So yeah, it's a string. So I need to turn it to int. Number equals to int. So I change this to n. I'm going to do the same thing over here. And and so the same thing happens here. So nowadays we have a lot of repeated codes, and maybe somehow let's check whether this code works. Oh, false. It seems like there's something wrong here. And oh, it's not here it's not ij. This is column row. This is row plus I column plus j. And I should put this row column. I should put this down. Yeah, that will work. And I'll check another example. All right. Seems like it's working now. And you can do maybe let's look at it. Let's see whether we can do some simplification. Let's just copy this and see whether it works here. Let's see, then fix. Submit. Yeah, it works. So this method, you can see there. This is one nested for loop, another nested for loop, and another nested for loop. So, and this one is like, so the space complexity would be all of n if you say like the matrix, the body is n by n. So it's all of n, and the time complexity would be all of n squared because the nested for loop. And that's it.